Right, so here we're going to look at different ways to chart or sort of visualize different types of data. All right, so I've got a set of data here. First of all, a piece of data, we call a data item, just a quick definition for you. And here's an example of maybe a sample, or this could be the whole population, it doesn't really matter, but I'm going to call it a sample. I've got students, the ages of students in a class. So I've got 18 numbers up here. That's 18 students in the class, or maybe it's 18 out of 50 students. I don't know. It could be a sample, it could be the whole population. It doesn't really matter. Right now we're just looking at the data itself. And so I've got the different ages for each the age for each student. No one has more than one age, I hope. Anyway, so we're going to look at different ways of representing this data. As it's written, just a list of 18 numbers, it's not really clear. You can't really draw any sort of conclusions or generalizations about that data. It's just a bunch of numbers, right? I mean, you could maybe pick out some characteristics. I see a lot of numbers in the teens there, a few 20s, 130. So there are just some things you can kind of pick out, but you don't really get a good feel for those the nuances there. So what we're going to do is look at what we call a frequency distribution first. And what that is you're going to take each data value, and you're going to list out the number of times it occurs, the frequency, okay? So, and I would list these out in order too. So I'm looking at the data, I see 16 is probably the lowest number, followed by 17, 18 is on there. I don't see anything lower than 16, right? 19, I should know, I just wrote this. 20 is on there, 21 is on there, 22 is on there, 25, and 32. Okay, so these are the different ages within the class. And so the frequency distribution, you have your value there, your data value. The frequency distribution then has another column where the frequency, the number of times it occurs, is listed, okay? So the number 16 occurs once. Okay, so I put the number 1 there. 17 occurs once. Yes. 18 occurs 1, 2, 3, 4 times, 5 times. Almost missed that one. There's 5 of those. The number 19 occurs 1, 2, 3, 4 times. The number 20 occurs once. 21 occurs twice. 22 occurs 1, 2, twice. 25 occurs once, and 32 occurs once. Okay, so there's your frequency distribution. It's just the number of times that occurs, that each individual value occurs within the list. Now, one thing to note is that your total here, if I added all these frequencies together, you should get the 18 for the total number of items there. 5, 9, 10, 11, 12, 14, 16, 17, 18. So you get 18 total, and that is what we call the n value, and then for number, I suppose, it's the number of values, number of items, sorry, the number of data items that are collected, okay? So the n value is 18, and that adds up from the frequency, all right? So that's one way to get an idea. And then, of course, you can see from the frequency distribution, you can get a better feel for some tendencies within the data. Definitely, the 1819 is very largely represented here. Everything else is a 1 except the 2122 is 2, but even that's not a large frequency, and relative to the 5 and the 4. So you get a little bit better idea. Now, a grouped frequency distribution can be a little nicer in some sense. Basically, we group these into categories. And so maybe we take all the teens, all the 20s, and all the 30s together, something like that. There are other ways you could do maybe every 5 years, 15 to 20, 15 to 19, 20 to 24, 25 to 29, 30 to 35. You could do it that way. There are many ways you could do a grouped frequency distribution. I'm just going to go every 10. So we'll say teens, 20s, and 30s. And so then you're just looking at the frequency of each of those categories occurring. So people in their teens, 5, 9, 10, 11. So there's 11 of the 18 are in their teens, okay? 20s, 1, 2, 3, 4, 5, 6. 6 of the 18 were in their 20s, and 1 was in their 30s, okay? So in that particular sample, you have it broken down into these categories, and you can see the corresponding frequency. Definitely, the teens are significantly more populous within that sample. Okay. Okay. So now we can actually put these to a graph. A couple different types of graphs we can use. All right, histogram and a polygon. The polygon's a little bit weird. It's not a true polygon. But we'll talk about what that means in a moment. A histogram, let's just take the grouped frequency distribution for a moment, just because it's going to be quicker and a little bit simpler to sketch out. So a grouped frequency distribution essentially takes the range or the category, puts it on a horizontal axis. So you would have vertical, horizontal, and you'd have the teens, you'd have the 20s, and you'd have the 30s, sort of listed out on that horizontal axis there. And then vertically you have the frequency. So maybe you have going up to 12 here, and then I'll cut that in half and go 6, 9, 3, and then cut those in thirds so I get my individual values. 8, 7, 11, 10. So I have a pretty good scale there, however you want to set that up. So teens go up to 11. So you're just going to have a histogram. It's like a bar graph. You just have, so it'll be a bar that goes up from the bottom up to 11. Let's see if I can do this relatively straight. It's not bad. Easier going down than up. Okay. So there's the first bar of my histogram. Alright, so that's 11. Sometimes we'll put the number above it just so that it's clear what that is. Those in their 20s, there were 6 of them, so I'd come across from the 6. Whoa, that's not very horizontal there. Alright, so that gives you the 20s, and then the 30s, there was 1 of them, so that's going to be quite low. There it is. Alright, so this gives you an idea of a histogram. It's basically like a bar chart where you put bars over each category. The height of the bar represents the frequency that category occurred. You could do the same sort of histogram for the actual frequency distribution, not just the grouped one. You'd have each age listed out on the horizontal axis, and then you'd have numbers 1 through 5 essentially being measured as your heights. So you can go through and do that. You would just end up with 9 different bars rather than 3. Okay. Now a polygon is kind of weird. It's like a line graph almost. You take now the reason I say it's not a true polygon is because a true polygon would be closed, right? It's a shape made with sides that's a closed shape. This one's not closed. It's like connecting the dots. And so same sort of setup. I would have my teens here, 20s and 30s, and then up on top are 12. Could have sketched this out ahead of the video. Oh. It saved a bit of time. I apologize for not having done that. But isn't it fun seeing how this plays out? Maybe not. Okay, so there we go. And then basically you put a dot at each of the frequencies and connect them with a line. So the teens, you go up to 11. Let's see, if I can get this to actually come out nice. There's one of them. Then the 20s were at 6. There it is. And then the 30s were at 1. And then you just connect them. Now this is not one smooth line, although it turns out to be one smooth line. That's not actually good for my example. Because the drop is consistent, it's 5 each time. I didn't actually plan that. But you basically connect the dots. One right there, one right there. Now typically it won't be a nice continuous line. You know, it may be, in general, it might go up and then come down and then go down steeper and then come up again. It might be something weird like that. But we call it a polygon, even though it's not closed entirely. It's just a bunch of line segments connected together where the vertices of those line segments are going to be at the frequency values. Okay, so it just kind of gives you a trend almost. You know, when you're looking at the lines that connect them, line segments that connect them. So that's polygon, maybe a bad example because it was one continuous line segment essentially, but generally that, you know, they'll change direction as you go. Okay, hopefully you get the idea there. Finally, we also have this thing called a stem and leaf plot, or a stem and leaf chart. And so, or a plot, yeah, stem and leaf plot. And so basically what we do, and this is going to look a little bit more like the grouped frequency distribution, just kind of a variation. We take the values here and we look at the digits. You have the tens place and the ones place. And you can take, you know, the teens. So the tens place would be your stem. The ones place would be your leaf, essentially. And so you have stems of 1, 2, and 3. And then the leaf is basically you list off all of the data items, not the values, but the items themselves, individual ones. You can repeat basically. You list off all of the items that have a 1 as its tens place. So you have 8, 9, 8, so you're looking at all the ones places now. So 8 is the first one, a 9, an 8, an 8, 9, 9, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. I need 3 more. I'm running out of space. 6, 9, 8. I gotta get 6, 9, and 8 in there. I'm gonna erase and shrink this just a smidge. 7, 8, 6, 9, 8. There it is. So there's 11 numbers, and that should match the frequency for the from the group frequency distribution as well. Then you look at the leaves for the 2 for the 20s. So you get a 2, you get a 5, you get a 1. Get a 0, a 1, and a 2. Okay, so there we have our leaves for the 20s, and then for the 30s, there's only one of them, and it's a 2. So you have your leaf for the 30s. Okay, so that would be considered a stem and leaf plot, basically where your stems are the tenths place, your leaves are the ones place, and you just list off all the ones places that fall, within those tens places, And that gives you, it's kind of a variation of the two ideas here. You kind of are combining the frequency distribution with the histogram, and so you can see the number, the actual values there, and it kind of is like turning these histograms on its side almost, right? So you have 11, a height of 11 there, a length of 11 numbers, so you can kind of judge the relative size of each category based upon the length of the number of things written out, okay? So it's kind of a combination of these. The stem and leaf is kind of a cool idea. Anyway, these are just different ways to represent both visually, that's visual as well, and and numerically, kind of representing the data that was collected.